than ever before.
Continuing the legacy.
We are back.
Are you ready
to witness
the dawn of a new era?
This time,
with an all-new avatar.
Presenting continuing our previous legacy of Horizon techfest.
Horizon 2022. Horizon 2023. Horizon 2024.
From milestone to new horizons. 3, 2, 1. The countdown ends and the innovation begins. Welcome to Horizon 2025.
Horizon 2025 presents the following competition.
Techfest is a platform for budding technologists to present innovative technical ideas and solutions to a panel of experts. On-Spot Quiz is a dynamic and interactive quiz competition designed to test participants' knowledge under pressure. Cinetrix and Animation is a creative platform for aspiring filmmakers and animators to showcase their storytelling abilities through short films and animations. Game of Thrones is a competitive gaming event where participants exhibit their strategic and technical prowess across popular games. Papyrus offers participants an opportunity to present well-researched technical posters, showcasing groundbreaking ideas and innovations.
Robotrix is a multi-event robotics competition featuring challenges like all-terrain vehicle ATV for disaster management, robo-war, drone exhibitions focused on precision agriculture, AR/VR applications, and maze-solving robots.
Circuitrix challenges participants to solve circuit-based puzzles and identify missing components in a given circuit system. Y Combinator is a website design competition that focuses on UI or UX design for web or mobile applications. Code It Now is a high-pressure coding competition where participants compete in the categories fastest code execution and least backspace usage. Bug Bounty is a competitive debugging challenge where participants identify and resolve bugs in provided code bases. Hackmaze is a problem-solving challenge where participants navigate mazes and grid-based puzzles to arrive at optimal solutions. Build India focuses on innovative project presentations promoting sustainable growth under the Make in India scheme.
Startup Synergy is a dynamic techfest event featuring a business plan pitch competition where aspiring entrepreneurs present innovative startup ideas to a panel of expert judges.
Mechvation consists of 2 core challenges, a mechanical drawing and design contest and a gear assembly challenge. Verdict West is a structural design and technical drawing competition where participants create detailed and accurate designs to solve real-world engineering problems.
Virtual Visionaries Battle is an exciting and innovative competition designed for tech enthusiasts.
Thank you, everyone. I hope you like the video presentation. Now I would request Professor Debadrita Sen ma'am to continue with the program.
Thank you, Janavi, and a very good afternoon to one and all present here. It is indeed a great privilege and honor to host a prestigious event like this today. We all know that music has a unique way of touching hearts and setting a perfect tone for any kind of a grand occasion. As we gather here for the inauguration of techfest Horizon 2K25 and the launch of our IEEE MTT-S student branch chapter, let us commence this auspicious event with a melody that resonates with harmony and inspiration. And to do the honors, may I now invite Professor Shohini Ganguly, Head of the Department, Medical Lab Technology from Dr. B.C. Roy Academy of Professional Courses, Durgapur, to grace us with a soul-stirring inaugural song. Ma'am, please.
Good afternoon, everyone present here. I am Shohini Ganguly, Head of the Department, BSc in Medical Lab Technology Department, Dr. B.C. Roy, Academy of Professional Courses. It's an honor to be present in front of you all. And as an inaugural song, I am going to present Ei Akashe Amar Mukti Aloy Aloy, Rabi Thakurer গান। আমার মুক্তি আলোয় আলোয় এই আকাশে আমার মুক্তি আলোয় আলোয় আমার মুক্তি ধুলায় ধুলায় ঘাসে ঘাসে এই আকাশে আমার মুক্তি আলোয় আলোয় এই আকাশে আমার মুক্তি আলোয় আলোয় দেহ মনের সুদূর পারে হারিয়ে ফেলি আপনারে দেহ মনের সুদূর পারে হারিয়ে ফেলি আপনারে গানের সুরে আমার মুক্তি ঊর্ধ্বে ভাসে এই আকাশে আমার মুক্তি আলোয় আলোয় এই আকাশে আমার মুক্তি আলোয় আলোয় আমার মুক্তি সর্বজনের মনের মাঝে দুঃখ বিপদ তুচ্ছ করা কঠিন কাজে আমার মুক্তি সর্বজনের মনের মাঝে দুঃখ বিপদ তুচ্ছ করা কঠিন কাজে যোগ্যদাতার যোগ্যশালা আত্মহোমের বহ্নি জ্বালা বিশ্বধাতার যোগ্যশালা আত্মহোমের বহ্নি জ্বালা জীবন যেন দিয়াহুতি মুক্তি আসে এই আকাশে আমার মুক্তি আলোয় আলোয় আমার মুক্তি ধুলায় ধুলায় ঘাসে ঘাসে এই আকাশে আমার মুক্তি আলোয় আলোয়।
Thank you, ma'am, for your mellifluous and elegant rendition. Let us now initiate this part of the program with a traditional yet meaningful gesture of watering the plant, which symbolizes growth, knowledge, and sustainability. And to do the honors, may I now invite our esteemed dignitaries on the dais to water the plant and mark the beginning of this auspicious journey. May I also request our students, volunteers, to kindly help our dignitaries to the dais. With utmost respect, I would like to invite our chief guest of the day, Honorable Professor Dr. Gautam Chattopadhyay, Senior Scientist, NASA's Jet Propulsion Laboratory, California Institute of Technology, USA. Sir, please. Our guest of honor of the day, Honorable Professor Dr. Bhaskar Gupta, Vice Chancellor, Jadavpur University. Sir, please. Honorable Sri Torun Bhattacharya, General Secretary, Dr. B.C. Roy Society, Durgapur. Sir, please. Honorable Dr. Shotajit Bose, President of Dr. B.C. Roy Society and Chairman, the Mission Hospital, Durgapur. Sir. Honorable Professor Dr. Shoikat Moitro, Chief Advisor, Dr. B.C. Roy Society, Durgapur. Sir, please. And Honorable Professor Dr. Sanjay S. Power, Principal, Dr. B.C. Roy Engineering College, Durgapur. Sir, please. May I request our student volunteers to kindly assist our dignitaries with the proceedings. Ladies and gentlemen, a big round of applause. Thank you, sir. Thank you, students. Before proceeding with the felicitation ceremony, may I also have the honor of requesting Honorable Sri Janal Singh Sir, Treasurer, Dr. B.C. Roy Society, to please come to the dais and grace the occasion. Sir, please. Students, I request you all to kindly help, sir, to the dais. It's a felicitation. Yeah. We have to wait for the felicitation, sir. To commence with the felicitation ceremony, may we now invite Sri Janal Singh Sir, Treasurer, Dr. B.C. Roy Society, to felicitate our chief guest, Professor Dr. Gautam Chattopadhyay, and guest of honor, Professor Dr. Bhaskar Gupta, with a flower bouquet. Thank you, sir. Thank you, students. Next, may we request Sri Torun Bhattacharya, General Secretary, Dr. B.C. Roy Society, Durgapur, to extend our heartfelt gratitude to our chief guest, Professor Dr. Gautam Chattopadhyay, and guest of honor, Professor Dr. Bhaskar Gupta, and welcome them with a Uttarya. Thank you, sir. Thank you, students. May I now request Dr. Shotajit Bose, President, Dr. B.C. Roy Society, and Chairman, the Mission Hospital, Durgapur, to kindly honor and felicitate our chief guest, Professor Dr. Gautam Chattopadhyay, and guest of honor, Professor Dr. Bhaskar Gupta, with a memento. A big round of applause, ladies and gentlemen. Thank you, sir. Thank you, students. May I once again request Sri Torun Bhattacharya, General Secretary, Dr. B.C. Roy Society, to felicitate our chief guest of the day, Dr. Gautam Chattopadhyay, and guest of honor, Dr. Bhaskar Gupta, with a small token of our gratitude and appreciation. Sir, please. Thank you, sir. Thank you, students. With this, may I request our honorable dignitaries present on the dais to kindly take their seats in the front row of the auditorium, while I request our principal, sir, Professor Dr. Sanjay S. Power, to kindly deliver his inaugural address. Sir. So please.
A very good afternoon to all of you on this occasion of our TechFest Horizon 2025. Today's chief guest, Professor Gautam Chattopadhyay, Senior Scientist, NASA Jet Propulsion Laboratory, California, Institute of Technology, Vice Chancellor of Jadavpur University, Honorable Bhaskar Gupta sir, Chairman of our society, Dr. Satyajit Bose, Chief Advisor, Professor Saikat Mitra, General Secretary sir, Sri Tarun Bhattacharya, Treasurer sir, Journal Singh, society members, head of the departments, faculty members and students. Today, on the occasion of our Silver Jubilee celebration, I am really very happy to have the stalwart here on our campuses. And sir, with the presence of here itself, probably there could be a lot of inspiration into working towards one of the goals that today we had is inauguration of an MTT-S chapter of IEEE. On the occasion again of the inaugural function of TechFest, this is one of the great achievement which we can say, a great start which we can look forward for the inaugural of MTT-S chapter. The principal organization of which I am also part since last 30 years. And I have been gaining with respect to this membership of these activities. Today we will listen to these stalwarts and also understand where we stand here today, what is the difference and what are the futuristic actions. There has been a huge differences between what are the goals and what are the present situations. We also look towards the various categories of the competition which we have today. Probably that could lead to the different direction in which each of our students will be a part of the competition and how they can reach to the next level of the competition outside world. Building the basic blocks at the initial stages, probably starting from the first year right participation, second year, third year right, until you reach to the third year and final year. There are lines of competitions available outside. One of them again is the Smart India Hackathon. Another again is from IEEE Extreme itself, probably I think some of the people are knowing. These are some kind of examples and the competitions which will really test your caliber from the technology point of view, from the knowledge point of view, from the skills point of view. And these competitions, the participation, winning, going ahead, the journey teaches you a lot. And this journey itself makes it a very interesting, enthusiastic, and inspirations. The field today, what our stalwarts or the chief guest will be explaining is maybe again the MTT-S chapter, which is, I still again remember, is one of the most renowned chapter which we can say where a lot of fundings are available. In fact, today sir itself at the inaugural of our MTT-S chapter said, if we catch up with some kind of a membership, $1,000 of the grant will be there from the IEEE section. Not only this, I still remember maybe a couple of years before when I was in IEEE Bombay section, lot of projects, fundings are available for the faculties and students in this area. Only thing which I feel is again the awareness among that problems, statements, and what are the challenges that are coming to us. So this chapter probably will be a bridge to the faculty members as well as the students to understand into the area where the futuristic challenges are there. Of course, again, I'm also from electronics and telecommunication part and that area. MTT-S, of course, is one of the toughest subject which I can understand, but once the things are taken into right direction and proper understanding, it could be one of the easiest part and so. Once again, I welcome you, all of you here. Thank you, sir, for being here. And again, I'm repeating, your presence should inspire most of our students to look into this area, into the working and solving the world problems. Thank you very much.
Thank you, sir, for your encouraging and insightful words. May we now have the honor of requesting Professor Dr. Shoikot Moitro, Chief Advisor, Dr. B.C. Roy Society, Durgapur, to kindly deliver his welcome address. May I also request our student volunteers to kindly help sir to the dais. Sir, please.
Good afternoon. Today's main center of attractions, Professor Bhaskar Gupta and Professor Dr. Gautam Chattopadhyay. They are the main speakers today. And we are really, excited to listen from them. I know Professor Bhaskar Gupta since a long time, maybe for the last 10-15 years. And I know he likes to spend more time among the students. And I know the topic which has been assigned to him, he doesn't like to remain constrained within this topic frame. And that is when last week only we shared the same day as at some other place. And Dr. Gautam Chattopadhyay, of the late, probably many of us have seen in newspapers, in televisions, his active presence. And his interactions, he is with the different, these people. And here, you see, to celebrate or to observe these 25 years of existence, we decided that we will bring here numbers of luminaries and doyens in different fields for encouraging, motivating our learning community. And we have witnessed here the deliberation from ISRO, from NASCOM. Today we are fortunate enough from NASA. Dr. Gautam Chattopadhyay is here. He will be presenting many things. And you see, this is the time to develop our own culture. Many times I quote these lines of Dickens, the best of time and worst of time. We have witnessed Sam Altman, the founder and key person of OpenAI, when he came in last year, arrogantly denied that the importance of India in making their own large language model at Bangalore. And only a few days before, 1 month before, he was compelled to come back to India after this breakthrough innovations of Feng Wang in the form of DeepSeek to appeal to Indian entrepreneurs to use all the tools, supports of OpenAI for developing SLM. We have seen that the government of India has taken a massive initiatives in establishing chip manufacturing centers at different parts of this country, including this state. We have seen unprecedented global tensions in the form of these geopolitical situations and environmental challenges. Of course, the most powerful man on this globe, he doesn't believe the importance of environment right now. Probably in due course of time, he will realize that all this technological development requires a massive impact. This creates a massive impact on environment. Chip making itself requires huge quantity of fresh water and all these things. And there's an unprecedented war among these world giants, how to go ahead in framing different, these ultra versions and next gen versions of chips, AI-enabled chips. So all these new things are coming up, bringing new opportunities. Only one thing is required, that is nurturing our passion. We, this community, Bengali community, worldwide, we are adored and appreciated for our logical and mathematical minds. And the testimony here is himself is Dr. Chattopadhyay. He went to US, he did his academic studies complete over there, and then he is occupying one of the key positions as Jet Propulsion Laboratories at NASA. So we are always, this intellectually superior, but many times we are not in a position to leverage the potential, the hidden potential which is existing in all of us. Now we are trying our level best in bringing a culture of research over here. And this is for our guest, you'll be happy to know that this engineering college has attained a status of autonomy. We are trying our level best in establishing a self-financed university very soon. And we are, this continuously giving our maximum endeavor in developing the proper ecosystem, in building, these entrepreneurial cultures, innovative cultures, enterprising, mind-bearing cultures. So today, this is my appeal to all the students and all others who are this interested to make themselves upgraded. Everything should have an outcome. So this day's outcome should be an added, this level of knowledge to our existing state of affairs, from the deliberations of Dr. Bhaskar Gupta first, and then Professor Dr. Gautam Chattopadhyay. I believe that all of you will be engaged in active listening. That is now has become a scarce, this quality or attributes among many of us. This keeping our attention level intact and keeping our focus and listening power intact. So my appeal, try your level best, engage yourselves in active listening. Active listening means whenever you are listening, you try to take a note of whatever you have learned, and afterwards you try to validate of your understanding of this presentation and deliberation. Then only your, this purpose of spending time at this auditorium will be useful. So without wasting further time, because this is the day for Professor Bhaskar Gupta and Professor Gautam Chattopadhyay, I am also eagerly waiting to listen from them. So I would like to express my sincerest thanks to both of them for responding to the call of this B.C. Roy Society, for taking a pain to come over here, taking this arduous journey from Kolkata to this place, and agreeing to deliver a lecture period of 45 minutes duration. That is as good as a class lecture time period. So wish you all the best. Wish you all of you happy, engaging, and enriching learning. Thank you very much.
Thank you, sir, for your warm and welcoming words. Before inviting our guest of honor today, ladies and gentlemen, allow me the honor of introducing Professor Dr. Bhaskar Gupta, whose remarkable expertise, leadership, and commitment to the academic excellence have paved way for numerous students and scholars to excel in their field. Honorable Professor Dr. Bhaskar Gupta, Vice Chancellor of Jadavpur University, was born in Kolkata, India in 1960. He obtained his BE, ME, and PhD degrees in Electronics and Telecommunication Engineering Department, Jadavpur University, in the years 1982, 1984, and 1996, respectively. He has been teaching since 1985 in the Department of Electronics and Telecommunication Engineering at Jadavpur University. He has published numerous research articles in refereed journals journals and conferences, and co-authored 3 books of advanced research topics. He is a senior member of IEEE, Fellow of IETE, Fellow of Institution of Engineers, India, and life member of SEM-CEI. He was the chairman of West Bengal Center, ET Division of IEI, and vice chair IEEE Kolkata section. He served as referee, associate editor, and guest editor in different internationally acclaimed journals. His present area of interest is planar antennas, implantable and wearable antennas in microwave engineering and antennas. He has published about 200 research articles in refereed journals, including IEEE Journal and conferences, and has co-authored a number of books on advanced research topics published internationally. He was the chairman of AP-MTT Joint Chapter, IEEE Calcutta Section, and chairman Student Activities, IEEE Calcutta Section. He has served as referee in different internationally acclaimed journals and guest editor to Asian Journal of Physics. With this, ladies and gentlemen, may I request Professor Dr. Bhaskar Gupta to kindly address the gathering with his insightful presentation on the topic, Technological Advancements through Artificial Intelligence, Pathway to Achieve Sustainable Development Goals. Student volunteers, I request you all to kindly escort Sir to the dais. Sir, please.
Anyway, is it ready to? Okay, আমি বলবো যখন প্রেজেন্ট করবেন হ্যাঁ Well, I see before me some truly eager young faces who always gives me energy, inspires me, and that's what truly keeps me going. So, a very good afternoon to all of you. Of course, many luminaries are here, but above all, so many students are here who are closest to my heart. But before I start today, I must confess that there had been a little bit of misunderstanding in the sense that the topic suggested to me was something which was read out, which was actually combining AI and sustainable development, the buzzwords now. But then when that was suggested, I actually told the organizers that you'd get so many people to talk on these topics. I would rather deliver a talk on again something truly close to my heart. I don't know whether you'd be interested in these or not. If you truly want to hear something about artificial intelligence and sustainable development, let me tell you a few words because I find that the correction had not been made. So just a few words. Talking of AI, artificial intelligence, do you think that it's a new development of this 21st century? You all think so? It's the upcoming thing. And it's an absolutely fresh thing, something truly. But is that true? I find a great mind, nodding in disagreement. It's not anything new at all. It's all very old. All the algorithms, they started with the neural modeling and the evolutionary algorithms for optimization, blah, blah, blah. They were there for past 75 years or more. So what's new? What's happening now? nothing but a development in hardware. Everybody is talking about development in software, in AI. But these were there. Even the statisticians did AI. They did not say it. They said regression analysis. But same thing, predictive modeling. Basically, it's the same thing. Only thing is that at that time, our data processing capability was limited. We could not handle so much of big data. Now that our hardware has developed, we can handle so much of big data, so much of data, and that's why our algorithms are providing more accurate results. Then whatever we are doing is just putting a bit, changing a bit here, and putting a little bit of modification there and all those things. I don't consider it something to be new, so that there's something to be really to be so much excited about. It is an old thing, old wine in new bottle. But whenever the bottle, at least the bottle is new, so much data processing, that's new due to the development of hardware. And that's where, in fact, microwave theory and technique, today we had inaugurated the MTT-S student branch here. That's where the role of MTT comes in. Well, software is, the concepts are old. Hardware is new. We are making continuous breakthroughs. When we were student, we were taught about some speed of, why were we taught? Even when we started research, a computer of speed, CPU speed 25 megahertz. Oh, that's great, that's great. Now, well, so many gigahertz. So how is it happening? Not because of software, because of hardware. And in the talking of microwaves, we cannot go without microwaves. Because at least if nothing, you're all using this thing. We are all using this thing. What's the frequency range? Again, microwaves. And the microwave devices, in our student days, we were taught about vacuum tubes. We were, even for solid state, we were taught with the silicon devices, gallium arsenide device. Now we are talking of gallium nitride, GaN, and newer materials, newer devices. That's hardware. So it's no use making AI such a hallowed thing. Just think of it holistically. We are developing in terms of hardware, and software AI is simply taking advantage of that. But it was there, it will be there. So that's about AI. So definitely any development for the future would utilize the technology. But remember, it's not due to AI. I would say it's due to development in hardware, essentially. So don't put your focus in a different place, different region. You may agree with me or you may not. But I think that's the fact. And secondly, whenever any such path-breaking development takes place, think of the time of industrial revolution. In fact, we have come through industry 4.0, now we are talking about industry 5.0. That was industry 1.0. Industrial revolution during the time of 18th century, and then again the society changed. And there were two aspects of it. One aspect was, of course, technological. It allowed people more rest to take production to a newer height at the same time. But another aspect was societal, sociological. So that sociological aspect also remains everywhere. Now, in this era, when we are harnessing, I repeat, the hardware to make these developments utilizing AI and other tools, we must think of the societal consequences also, not because of AI, because of this industrial development, because of this scientific development. Because what type of societal consequences I am talking about? The society changes through such industrial revolutions, but the change must lead to a way which is not self-destructive. That's what we mean by sustainability. Now we are understanding. Now we have come to the understanding of how much damage to our Mother Earth we have caused by the development of plastics. Professor Moitra was just now talking about those aspects. You know, the marine life is getting destroyed because we are getting lots and lots of tons of plastic from within the stomach of whales and other marine life. So they are facing extinction. And you know, extinction of a species means so much disturbance in the biosphere. It's all very finely balanced. So that balance gets sorry. And in the same way, we can think of global warming. This is the end of February. In my childhood days, even at this time, it was pleasantly cold. Now, you know it. Where the temperature is reaching. You know it now. You know what's happening. I heard from Dr. Bose that he was in Alaska, it was hot due to some fire. But apart from fire also, I was in Belgium almost throughout January. I went with a huge big suitcase. Almost all the winter wear was of no use. I expected, because it was predicted -2 to -4 degree, but maybe for one day or 2 days. Otherwise, it was even 7, 8 degree. Pleasant Kolkata winter in my childhood days. So it was rather enjoyable. But in few more years, will it be enjoyable anymore? No. That's the point. You see, I'm going back. Even when we knew the story of the inside of atom and we came across the famous equation E equal to mc square, even Einstein could not realize at the time so much destruction can be created by it. When he realized, he tried to stop the process, but it was too late. He was a pacifist till the last breath of his life. But why he contradicted such application of his own theory? For the simple reason that whatever we do, whatever development we make, we must keep in mind that that should be sustainable. It should not be self-destructive. You know? So, and the same thing I think was being talked about with Dr. Bose about during our lunchtime about the antibiotic resistance that we had acquired in India. Why? With the development of so much antibiotic and their availability over the counter, we are misusing them. Again, misuse of technology. We are misusing pharmaceutical technology. That's why we now get no result from the latest antibiotics. That's sustainability. That's what forgetting about sustainability leads to. So whatever we do, let us come back to where we were. Whatever we do, we must keep in mind that we must apply it. Of course we'll apply it. Of course, because any scientific development, any technological development always ushers in a new era where mankind can be led to newer and newer heights. But when we do it, we must keep in mind that we should not do anything which is inherently self-destructive. We must keep in mind that. Okay? Similarly, for the case of AI, we can utilize it in many, many, many ways for augmentation of human life, for betterment of human life. But if we are blind, we'll end up in utilizing these two in ways which would be inherently self-destructive. So I think since you were keen to know something about those topics, even without these slides and without getting prepared, I tried to share some of my thoughts with you. Now I come back to the lecture that I thought, the presentation that I thought I would present before you. Actually, you know, all these have been made possible by the forbearing works of our forefathers. We are standing on the shoulders of them. Otherwise, we are simply midgets. So, this is just a little tribute to them. Why to them? Why to all of them? No. It's a tribute to the doyens of communication from Kolkata. You know, my city, Kolkata, I love it, by the way. I love Bengal, I love Kolkata. My Kolkata has always been in the forefront of wherever that's Indian. It is always the cultural capital, but for one, we boast of all the Nobel laureates in India. It's the cultural capital, if now it is. It's the scientific capital too. And that is why in all the developments in communication, my subject of Professor Chattopadhyay, subject of so many of you here, that develop all the communication frontiers also, we contribute, I mean, those on whose shoulders we are standing, they contributed a lot. And this is just a tribute to them, to show you our true legacy. So, saying these few words, I start a journey in describing very briefly who they were and what are they doing. This one? Yeah, okay. Have you heard of this name? I'm sure you haven't seen the picture at all. Any one of you heard of the name William Brooke O'Shaughnessy? Of course you would, I know. Professor Chattopadhyay raised his hand. I asked the students. Only Professor Chattopadhyay, only my friend and my brother Gautam knows about him. But he is a man whom we should never, never, never forget, whom we cannot afford to forget. Well, a line of description follows here, of course, that who was he? No, he was the father of Indian telegraph. What does it mean? What did he do? See? I think the lines are self-explanatory. He laid 11,000 miles of telegraph cable from Kolkata all the way to Peshawar, because all of these were then in British India. Unimaginable engineering feat. And second line, look at that one. He laid that's something extraordinary, truly. That's a true engineering feat. He laid the first submarine telegraph in the world, even before the Britishers, before the Americans, before everybody. That was done in India. Okay. Below the Ganga. Well, and most interestingly, he developed indigenous materials and techniques using, that's again unimaginable. Absolutely native materials like bamboo poles, iron sticks, because he had nothing else available to him. No exotic material, nothing. With them, he made fantastic innovations. So he was innovator par excellence. With them only. Well, nobody could think of that. He created some hybrid transformer and some other, all those initial telegraph equipment. That's why I call him a great man. He was, by the way, not English, but he was, I think you can guess from the name. I think you can guess, even if you cannot, let me tell you. He was Irish, yes, somebody said from there. He was Irish. And one more interesting point is that he was very fond of Indians with the Indian government. By that I mean the British government. He faced lots of issues because he stood up for the Indian coolies who worked with him in laying this telegraph cable. So he lost his job and he was sent back, but he had to be brought back again because of his key skills, because he was a true innovator. And then again he went back to his native village. About his last life we do not know much, but talking of O'Shaughnessy, you'd be surprised to know what he was by training. He was a medical doctor by training. In Kolkata Medical College, he was the professor of anatomy and chemistry. And by the way, an innovator puts his signature everywhere. So there also in the medical world, O'Shaughnessy put his signature. About the, nowadays in many American states also, marijuana is considered a medicinal plant. So the medicinal usage of these indigenous plants, that was first proposed by this man again through a very brief paper which again published in British Medical Journal about Dhutura, and which changed the medical concepts all the way. So he was a multifarious genius. In fact, it may be true, it's argued by some historians that why, I would not say what he was argued, but what do you think was the reason the Sepoys lost the Sepoy mutiny in 1857, which is described as the first war of independence of India? You can think of many answers. But many historians say that it was the deployment of telegraph. And the man behind it was O'Shaughnessy. Because of telegraph, as soon as the mutiny broke out in Barakpur, within 7 minutes, news reached Agra, and then the news reached all the way to Peshawar. So that's how the mutineers were defeated. Well, might not have ushered something good for the Indians, but the man, William Brooke O'Shaughnessy, did lots of good for Indians. He was, I repeat, a professor in Calcutta Medical College, as also a chancellor of Mint here in Calcutta, director Mint, sorry, and we have forgotten him totally. Only one picture is there depicting him in Calcutta Medical College, large lecture theatre, Calcutta Medical College. Almost nobody knows about him now. So let's move to the next slide. Well, I think although you haven't known about O'Shaughnessy, you all know about him. Acharya Jagadish Chandra Bose. Rather than telling what he did, I think it's very difficult to say what he did not. Because he did everything in radio engineering. He was a pioneer of radio engineering. He was, at that time, the heart of the radio engineering society. Let us try to enlist some of his achievements. Number one, he was the world's first microwave engineer. Nobody could think of utilizing microwave at his time. You know what is microwave? Microwave is simply a frequency range, roughly spreading from 1 gigahertz to 40 gigahertz, gigahertz range. And at that time, although the radio engineering started germinating, people were working at meter wave range. If you calculate, you would understand that in these frequency range microwave, the wavelength is at about of the order of centimeters at most. That is easily calculable by the simple formula. V is equal to C, velocity is equal to frequency into wavelength. C is equal to F lambda. And while Jagadish Chandra thought of working in microwaves and millimeter waves, even with wavelengths of centimeters and millimeters, people were working with meter waves. Nobody could imagine that this is possible, but this was the future, and even now what is lying in the future, Jagadish Chandra predicted that. In next generation communication, we are going for millimeter wave communication, mostly 60 gigahertz, and Sir J.C. Bose did his experiments at 50 gigahertz. In 1895, 1896, so he was almost 150 years ahead of his time. Such a great man. What he thought at that time, now we are thinking. And more interestingly, he was the first person to establish a complete communication link. Well, before him, Heinrich Hertz could experimentally generate electromagnetic waves for communication, but a complete link requires a complete holistic setup. That is the transmitter and the receiver, everything. He did it experimentally. And I'll show you his apparatus, a picture of it. And he was the first person to get a patent for a semiconductor device that was granted in 1904. That was granted for galena detector. Galena is lead sulfide to detect electromagnetic waves. Well, a receiver requires that, and as I said, without the receiver, no communication system is complete. And this galena detector was the first patent granted in the US for a semiconductor device. It was granted in the names of Mrs. Sarabul and Jagadish Chandra Bose, as it was written. Now, who was this Sarabul? I don't know whether I have that much of time or not. Very interestingly, this patent was taken by him. Just a minute. This patent was granted to him after his application done in the insistence of sister of Swami Vivekananda, essentially, through Sister Nivedita, who was a close friend, and but who would provide the money? Jagadish Chandra did not have the money, for his experiment. So while he was being granted DSc and being praised by Lord Raleigh and everybody in London, then another of his very close friend, Rabindranath, had to send him money for his experiments regularly. And Rabindranath also got skeptic, asked Nivedita whether the money is getting properly utilized or not, even though they were so close friends. But, at that time, somebody had to provide the money. Money was provided by this Mrs. Sarah Bull, a staunch disciple of Vivekananda, who is known among the Ramakrishna Mission circle as Dhira Mata, a wife of a wealthy businessman, Oli Bull, widow of Miss Oli Bull, widow of Oli Bull, sorry. That's why the patent contains the names of both. But essentially we all know that it was the handiwork of Jagadish Chandra. Very interestingly, both Rabindranath and Jagadish Chandra, they were very close friends, as I said. And I'll come to that part later. And then you see, well, this leads to another interesting story. First remote control engineer in the world. Now we are having remote control car, unmanned vehicles, driverless cars, drones, UAV, what not. Who was the first remote control engineer who demonstrated remote control for the first time? Again, Sir Jagadish Chandra Bose, the multifarious genius. The experiment was like this. The experiment was shown in Calcutta Town Hall, at that time Calcutta. He was sitting in one room along with the Lieutenant Governor and other dignitaries, Britishers. He casually pushed a switch, and in an adjoining room, a cannon burst. In fact, everybody was so surprised that beforehand, that these Indian gentlemen do not perform something, is not allowed to perform some sort of tantra mantra magic. The Lieutenant Governor, who is a portly man, himself guarded the room connecting the two rooms, the door connecting the two rooms. He stood there, but still it happened. Jagadish Chandra made the cannon fire. He fired the cannon from remote. First remote control experiment in the world. Oh, sorry. I should move the other way around. Well, the list goes on. As I've already told you, inventor of Galena detector, the first semiconductor device in history. He named it, he called it an invisible eye. First he named it as tejometer, then the history as it is known now. It was just called Galena Coherad at that time. He is a scientist responsible for establishing beyond doubt that light is an electromagnetic wave. Another very, very interesting story. That before him, lots of controversies were always prevailing there about the nature of light. Even Maxwell, James Clerk Maxwell, who proposed these electromagnetic waves, the existence of them, he was not sure whether light is electromagnetic or not. Sometimes he said yes, sometimes he said no. But what Jagadish Chandra did was unthinkable and so interesting. Experimentally, he showed that these electromagnetic waves follow the optical properties well known for light. So what was the inference? Very simple. Then they are optical in nature. Then that means light is electromagnetic in nature. So, beyond any doubt, it was established from that time only. Jagadish Chandra put the last nail on the coffin of the theory that light may not be electromagnetic. He simply demonstrated the well-known properties of light to be observed by these electromagnetic waves, like polarization, like diffraction. And for that, what he did, he just made some so-called polarizers out of practically nothing. His polarizers consisted of jute fibers, even a railway timetable. Unimaginable the way this great mind works. Oh my God, it goes on and on. I think, sorry. I'm moving, I have to move the other way around. He was the inventor, of course, of horn antenna and many other antennas and waveguides and many other such microwave device and equipment. This is the original millimeter wave communication equipment which is kept in Bosch Institute. By the way, that's another great work by Bosch Institute, so that among the Bengalis this science can be cultivated. And as Acharya described it, that equipment, the sketch drawn by his own hand. Actually, he was called Sir J.C. Bosch, but he was quite uncomfortable with it. So his friend Rabindranath rescued it from the problem by providing the title Acharya. Then he was comfortable. But while Jagadish Chandra was at the pinnacle of his glory as radio engineer, he suddenly left it all because he became interested in firstly biophysics. There also he did some fantastic contributions. He left some, but had he not done so, everybody says that the Nobel Prize was for his asking only. But he left it all suddenly. Nobody truly knows why, but actually he became more interested in the mysteries of life. Maybe there's a theory which is again debated that he had a son who had died in infancy. Nobody knows for sure, which changed his mind. Almost at the same time, his closest friend Rabindranath also was going through such demise of his very dear ones. Finally, his son too. And they became interested in the mysteries of life from two different aspects. Philosophical aspect and scientific aspect, maybe. Or may not be, nobody knows. Let us move forward. Another great man, the greatest Indian physicist of the 20th century. If Jagadish Chandra belonged to 19th century, he belonged to 20th century. Sir Chandrasekhar Venkat Raman, what did he do? Why is he greatest? He was the discoverer of the Raman scattering phenomenon, which changed the ideas of physics and the ideas of communication too, therefrom all the way. Before him, the only form of light scattering or electromagnetic wave scattering that was known was without any change in frequency or phase. That was Rayleigh scattering. He showed that, yes, frequency also can be changed. And from one spectral line, he got two spectral lines. Something like magic. That was Raman scattering, for which he got the first he had become the first Nobel laureate in science from Asia. And he was also the mentor of another great scientist, Krishnan, because Krishnan was not all the way from Kolkata. I haven't written much about him, but he was the first Indian director of Indian Institute of Science, Bengaluru, the great institute. And such a great scientist Raman was, so confident he was, that in 1930, the day Raman effect was discovered, 28th February, that's tomorrow, that's even now considered as a National Science Day in India. And in that year, immediately after he got traces of Raman scattering, what did he do? He bought a ticket by a ship to Sweden. Why? Because he was sure that he would get the Nobel Prize for this discovery, so he would be called. And if he knows it so late, he may not get the ticket in the ship. He was so confident. So what are his contributions in communication? His theory led to novel high-power optical amplifiers and gain flattening, that's a spelling mistake. In optical communication channels, gain must be flattened. all the toll frequencies gain must be same for a reliable distortion-free communication. These experiments of his provided the theoretical basis of optical fiber communication through the subsequent works by Narinder Kapani and others. Optical communication, fiber optics, that's the order of the day. But he was behind it all. Here he is with his spectrometer, which I was describing. And because we are talking from, we have inaugurated that IEEE, so that's why I put this slide. Milestone plaques, one in honor of J.C. Bose, Bosch Institute, another in honor of Sir C.V. Raman in India Nursery for Cultivation of Science, have been established by our own society, IEEE. And then comes unimitable Satyendranath Bose. He is the harbinger of the future. Even now, we do not know the extent of, complete extent of his contribution to society, contribution to science. You see, he formulated Bose-Einstein statistics. A class of subatomic particles follow an entirely different statistics. I am not going into the details. But these statistics were not known before him, which surprised even Einstein. And he proposed that, in fact, it led to these particles, bosons. Earlier, all the subatomic particles which we had known were the so-called fermions now. Now we have two classes, fermions and bosons. Bosons are named after Bose. Some people call them God particles. Well, I'm not talking anything about God. But interestingly, another great contribution was we knew so far about the liquid state, solid state, gaseous state, all these. He proposed the existence of a new state of matter, Bose-Einstein condensate. Now it is proved that that is indeed there. Actually, his paper was originally rejected, but he sent it to Einstein straight away. Einstein translated to German, and it got published. And so resubmitted it, it got published. That's why the names of both are entangled together now. But you know, another interesting fact that many years later, it was found that the spin quantum, that's a different story, can be integral, but he always, Satyen Bose considered Einstein as his mentor. When Satyen Bose thought of the same thing and told that to Einstein in his own inimitable language, Boro Babu bollen, oita hoy na. So he dropped the idea. Boro Babu means Einstein. And he worked extensively on the interaction of ionosphere with electromagnetic waves, ionosphere surrounding us. And that way he actually ushered in the era of quantum computing and quantum communication. That's hardware. That's the real place of development. My God, so many points. I did not think that I've written so much. He was dedicated always to familiarization of common man to the world of science. He made study and research of science in vernacular, his goal in life. And that's why he established Bongyo Vigyan Porishad and published the magazine in Bengali, Gyan o Vigyan. He believed that everything can be done in Bengali, in vernacular. If the Germans can do it, if the Russians can do it, we can do it too. Throughout his life, he worked to that end. Then there's another great man, greatest astrophysicist of 20th century, Meghnad Shah. Well, many people ask why Meghnad Shah did not get the Nobel Prize. If you look at the list of Nobel laureates, no astrophysicist was awarded Nobel Prize at that time, just the way no mathematician is awarded, because every time his name was proposed, it was said that astrophysicists are not physicists. They were not considered physicists at that time. Now it's a different story. So he derived Shah ionization equation, which made predicting the life history of stars possible. When a star can change from one form of life to another, how does a star end its life? Not only that, he made seminal contributions to thermodynamics, again a spelling mistake, but that way he became a forerunner of deep space communication. At the same time, just like Satyendranath, he was a leading social activist. Not only that, he was a champion of rationalism. He was a planner par excellence, the man responsible behind the planning of DVC. You see this Durgapur barrage, all this. He was an MP also at that time, and his speeches in the parliament are gem. I would urge everybody to read them. He was the founding editor of Science and Culture. His thoughts are all concentrated there, which makes even now a very, very interesting reading material. Then I come to the great man, another great man, Professor Shishir Kumar Mitra. I called him demystifier of upper atmosphere. Let me explain the reasons. I think I'm exceeding my time. How much time do I get? 15 minutes more at least? Professor S.K. Mitra, he was, I'm trying. He was a pioneer in studies on ionosphere. He discovered the one ionospheric layer, E layer. He explained the hue of the night sky, all this. And look at one similarity between all these great men. They all established one institute for the advancement of science. He established Institute of Radio Physics and Electronics affiliated to Calcutta University. But all this makes the man to be remembered always. Well, after that, my own professor, Professor Gyan Sharan Chatterjee, Gyan Sharan, whose only abode was knowledge. Truly, he was a leading antenna engineer of his time. I had the good fortune to be his student during his final days as teacher. He was the first scientist to propose the principles of frequency independent antenna design, a great contribution. He was the inventor of conical helix antenna, the beginning space communication antennas, which were in those days used very much when he contributed to them, starting from that conical helix, which retained over huge frequency band, its polarization and all characteristics. He established my own Department of Electronics and Scientific Engineering at Jadavpur University. This is that conical helix antenna. Gautam, you must be having this, no? Your place, because he developed it in NASA, if I remember correctly. And then I am showing the picture of another of my professors, Dr. Bishwajit Nag, and I call him the usherer of the digital era to India, because more than scientific contribution, because of his contributions in policy management, also scientifically, he actually, he led the team to build the first indigenous digital computer in our country way back in early 60s, ECU1. But his greatest contribution was that in the early days when India's technology development policy was nascent, he gave its form as the chairman of Electronics Commission. I think he was the second chairman or so. He is the person, that's why I consider he is the person responsible for the software power of India, for which India is so well known now. Because it was his idea that we have some great brains, so we must go for software development rather than hardware. And I'm almost coming to an end. Another great man, again connected to Calcutta, connected to my city. Narinder Singh Kapani, the unsung hero of optical communication. He is the truly unsung hero. Many of you know about the other names, but have you heard of Narinder Singh Kapani? Very few. You see, only from the first bench I get these hands being raised, which I expected, but the students do not know about these peoples. Why should we remember him? He started his life from Kolkata Ordnance Factory Board and ended by inventing optical fiber. He's a father of fiber optics. Not only that, he was entrepreneur, he was innovator. He died in the US few years back only, but he remained unsung. We did not know him. So this is my tribute to Narinder Singh. And these are some of the optical fibers, all due to him. I think this is the last gentleman whom I would talk about because he is the only living one among all these doyens, Monilal Bhaumik. He is living and a legend, so that's why he is a living legend, and that's why I did not include his photo, because in a photograph, somehow it looks still, rather a pencil sketch. He is the holder of numerous patents on high power laser technology. High power laser and Moni Bhaumik, the two names are inseparable. Actually, he developed excimer laser, which is applied in all sorts of applications over such broad range, starting from the medical applications, LASIK. Earlier, we knew so many people we had seen with these glasses like wearing glasses looking like the bottom of water carriers. The LASIK operation obliterated that. The power of the lens can be adjusted now using the developed excimer laser invented by Moni Bhaumik. Photolithography and manufacturing of microelectronic components, they also underwent a sea change, and that's what made the development of cell phones, this manufacturing of the small components possible. But at the end, just like Jagadish Chandra, he later became busy in search of the origin and meaning of consciousness. He made some interesting contribution, published some interesting work, no doubt. But let us confine ourselves to the excimer layer. Here it is. And I could have gone on and on because there are so many great men in the field of communication from my city. With my pranam to all those and thanks to all of you, I end here. Okay? I think I can take my leave now. If you permit. Thank you.
Thank you, sir.
My pleasure.
Thank you, sir. Thank you very much for your thought-provoking and erudite presentation. Should we start? Ladies and gentlemen, we are going to connect online with some of our guests. Should I start? Good afternoon, sirs. It is our great honor and proud privilege to welcome Professor Dr. Glauco Font Galland, MGA Vice Chair, IEEE MTT-S, along with Professor Dr. Chinmoy Saha, Chair, IEEE MTT-S, Region 10, and Associate Professor at IIST to this momentous occasion. Sir, we welcome you. We are extremely honored to host our distinguished speakers who have joined us on a virtual mode. to deliver their inaugural address on the auspicious opening of the IEEE MTT-S Students Branch Chapter at Dr. B.C. Roy Engineering College, Durgapur. Professors, we are proudly honored to have you here. Your expertise will undoubtedly inspire and empower our students on their journey to innovation and discovery. With this, may we request Professor Dr. Chinmoy Shaha to kindly start the session and enrich us. Over to you, Dr. Shaha. Thank you. Ladies and gentlemen, I apologize for this network glitch. With this, may I now have the honor of introducing our chief guest of the day, Professor Dr. Gautam Chattopadhyay, and brief you all about his work and achievements. Honorable Professor Dr. Gautam Chattopadhyay is a senior scientist at NASA's Jet Propulsion Laboratory, JPL, at California Institute of Technology, Caltech, and a visiting professor at Caltech in Pasadena, USA. He has previously held the position of BEL Distinguished Visiting Chair Professor at the Indian Institute of Science in Bangalore and served as an adjunct professor at the Indian Institute of Technology in Kharagpur, India. Dr. Chattopadhyay earned his PhD in electrical engineering from Caltech in the year 2000. He is a fellow of both IEEE USA and IETE India, serves as a track editor for the IEEE transactions on antenna and propagations, and is an IEEE distinguished lecturer. He will also serve as the 2025 president of IEEE MTT-S. His research interests include microwave, millimeter wave, and terahertz receiver system and radars, as well as the development of space instruments for the search for life beyond Earth. Dr. Chattopadhyay has published over 400 papers in international journals and conferences and holds more than 20 patents. He has received over 35 NASA Technical Achievements and New Technology Invention Awards in 2024. He was honored with the Armstrong Medal from the Radio Club of America, RCA, for his outstanding contributions to radio science. He has also received the NASA JPL People Leadership Award in 2023. He was named IEEE Region 6 Engineer of the Year in 2018 and received the Distinguished Alumni Award from the Indian Institute of Engineering, Science and Technology, IIEST India, in 2017. Additionally, he has won the Best Journal Paper Award from IEEE Transactions on Terahertz Science and Technology in both 2020 and 2013, the Best Paper Award for Antenna Design and Applications at the European Antennas and Propagation Conference, UCAP, in 2017, the IEEE Professor S.N. Mitro Memorial Award in 2014, and the IEEE Biman Bihari Sen Memorial Award in 2022. Ladies and gentlemen, without further ado, may I now have the honor and proud privilege of inviting Professor Dr. Gautam Chattopadhyay to present his deliberations on space exploration and our place in the universe. Ladies and gentlemen, a big round of applause for Dr. Chattopadhyay. Sir, please.
All right. Good afternoon, everyone. I don't know about you, but I am very excited to be here. And because, I grew up in a very small village, outskirts of Kolkata. And now when I come to India, I come very often. And I am invited to many places to give talk, IITs, IISCs. But I actually prefer to come to places like here. Because there are talents everywhere. You all are extremely talented. What holds you back is just your imagination. If you work hard, you are no less than anyone. Always believe that. Your hard work and your dedication can take you, far. So always think about that. So I am going to talk today about space exploration and our place in the universe. The title is big. It covers a lot of stuff. What I'm going to tell you a little bit about what we do at NASA. What is our role? And what is our role in this universe itself? So let's get going. So let me see which direction it goes. All right, before I start, you might see here that I have another affiliation. I am the 2025 president of IEEE MTT, Microwave Theory and Technology Society. So IEEE is one of the largest professional organizations in the world. Institute of Electrical and Electrical Engineers. You might say, I am doing mechanical engineering. What are you talking to me about? Right? It doesn't matter what you are studying. I'll show you that you can still be part of IEEE. And Bhaskar was showing you the smartphone. How many of you have this smartphone? I'm sure all of you have one, right? The question is, you don't have smartphone? Okay, amazing. If you don't have, I'm sure that all of you have one. The question is, how many of you opened your smartphone? Have you opened your smartphone? I don't think many have opened the smartphone. The reason is, it's very difficult to open your smartphone. You need to buy some special tools. Not that expensive, about $12. It costs on Amazon. You can actually buy those tools and open. I opened my wife's phone. Okay, because it was water damaged. Okay, that's why I opened it. But I'm asking this question for a reason. You can be an electrical engineer, you can be an electronics engineer, it can be a mechanical engineer, it can be a civil engineer, doesn't matter. Please open your smartphone. You are not going to break it, believe me. Once you open it, you will see inside what is it made of. you need an electrical engineer, you need a mechanical engineer, you need a thermal engineer, you need an antenna engineer, you need all kinds of engineering to make a smartphone work. So you can still be part of IEEE even if you are doing whatever you are doing in your field. That's the point I'm trying to make. And I'll talk a little bit about what I do, the IEEE part. And how many of you are IEEE members? Can you raise your hand, please? Student members as well? I'm so disappointed looking at the number of hands. You know how much it costs to become IEEE member? $15. What is $15? 15 times 85. How much you pay to eat a meal at McDonald's or Pizza Hut? Cost similar in that range. So you are not going to become a member of IEEE, but you are going to spend that money. I'll show you that you are really leaving a lot on the table by not becoming a member, because this is a professional organization that provides you networking opportunity. I am an IEEE member. I became an IEEE member when I was a student, and here I am. I'm the president of one of the largest societies, about 15,000 members around the globe. And we decide on what goes in a smartphone. What are the, all these new 5G, 6G, what are the standards? Who decides on the standards? We do. Join us. You will really learn a lot. You'll be able to network. Maybe your next job will come from the person you meet through this networking event. So here is the leadership of Microwave Theory and Technology Society. And then you can see the faces, they come from all over the globe. It's a global organization. And I'm not going to spend too much, but I'm just going to say a few things, because last year we actually reached about 14,000 members. So what we are trying to do, we have a lot of publications, but main thing is about students, opportunity for students. If you are an undergraduate student, you can actually join this society by paying $15. And then there are 20 plus undergraduate scholarships are available, $3,000. So $15 gives you $3,000 of scholarship. Just see the return on your investment. We do not get enough applicants from India. When we sit in the table to decide whom will get this award, we don't see applications from India. Because, you know why? Because you are eating that pizza and not becoming a member. That's the reason. I told you that what is holding you back is just your imagination. This is a lack of imagination. That's what's happening. So today, become a member, become an MTT-S member, and explore all these possibilities, what you can get. So all these different conferences that we organize, all this you can see here for PhD initiative. We have undergraduate initiatives, we have student paper competitions, and all kinds of stuff, 3-minute thesis. All not only give you this $3,000 fellowship, we will fly you from here to Durgapur to US to receive that award. We'll pay for your travel. Next time you are drinking that coffee in Starbucks, think what I said. Just go to mtt.org and you're going to find out. Okay, let's talk about NASA and what I do, actual subject that I wanted to talk about. So many of you heard about NASA. NASA actually has different centers all across the United States. Our head office is in Washington, D.C., and I am here in Jet Propulsion Laboratory in Pasadena on the West Coast near Los Angeles. Actually, NASA started from JPL. There are a few propulsion engineers at Caltech, California Institute of Technology. They're doing some propulsion experiments, and then the space race started because Sputnik happened, and then NASA was formed in 1958. But JPL started much before that. So again, this is JPL. We have about 5,000 employees. It's not that large organization. So if you look at this picture, that tells that we have been very busy over the last few years. These are all the different missions that NASA has launched, and we have taken part in those missions. And few of them are actually in the making. We will be flying few of them. Psyche is already flying, New Voice is already flying. So what we do? Sorry. So see, we can land a rover on Mars, but we cannot fix sometimes an audio and sometimes PowerPoint, right? So that is one of the challenges we always have. So what do? We dare mighty things. That is the motto of JPL. What we do, we study our home planet from space and try to understand what's going on. You heard about climate change. Climate change is the major problem that we are going to face, that humanity is going to face. We'll have to address that. We are talking about how it is getting hot. About just a month and a half ago, there was a huge fire in California, in actually Los Angeles area. The fire came within a block of our home. Lot of homes about 100 meters from our home were all burned down. We ran in the middle of the night with our lives and just with our passport, nothing else, and the laptop. It never happened before. It is happening more and more. So we'll have to really think what we need to do to address those. What kind of technologies we need to do to clean up the mess that we are creating ourselves. It's very important. We look for life beyond Earth. I'll talk a little bit about that, how we go about that. We are making robots where no human being can go. We are also exploring some of our solar system. So I'll talk a little bit about that. Let's start with, Voyager. Many of you have heard Voyager. Voyager 1 has gone the furthest any man-made object. How far it is? It is about 22 light hours away from us. We know about light years. This is light hours. That translate to about 24 billion kilometers. The distance between the sun and Earth is about 150 million kilometers. Just think about it, how far it has gone. So a man-made object, and it's still communicating with us. Of course, it is not sending YouTube videos. It cannot do that, It's so far away. But it's sending the data, I'm alive. This is what is happening. Very few bits of data, but still communication is going on. It is from so far away. So you'll have to build something that can last this long. We launched in 1970s. We talked about we heard about J.C. Bose just some time back. I am just showing because he's the father of wireless communication. Nowadays, we cannot live without wireless communication. And what J.C. Bose's work has done is this, replaced all those stuff, you can see on the right side, in a small device. Think about what it has replaced. All these video cameras, alarm clock, typewriter, cameras, think about everything. This is a computer with communication in a small package, right? How is it possible? How did it happen? Because of the innovation that has gone through. And actually, it was started by J.C. Bose. Okay, let's start about a little bit of science. This is the Big Bang Theory. This is not the Big Bang Theory you watch on TV. This is the real Big Bang Theory, because our universe, we believe, started with a Big Bang about 13.85 billion years ago. What is interesting is the first light of the universe actually came after 400,000 years after Big Bang. How it was detected is very interesting. Two gentlemen, they were working at AT&T Bell Labs. Their name is Bob Wilson and Arno Penzias. They are doing, 1960s, they are doing some experiments for communication. And when they are measuring their, the signal that they are detecting, they found some extra noise coming in the system, wherever they look. And they could not explain. Sometimes you do experiments in your lab, right? In your undergraduate lab, you do experiments and you do some measurements and you cannot explain, right? What do? To get marks, you said, it must be experimental error. Then you change the error bar a little bit and say, I'm done. They could have done the same thing. But they didn't do that. They started thinking, what is going on? And then they realized what they are detecting is the first light of the universe. The first, that cosmic microwave background radiation that came out after 400,000 years Big Bang, that's what they are detecting. And for that, they went on to win the Nobel Prize in 1978 in physics. So next time you do some experiment in your lab and you cannot explain what is going on, don't think it is experimental error. You might win the Nobel Prize, you never know, right? So I'm showing this picture for a reason. The person he's sitting here is Bob Wilson, who got the Nobel Prize, who detected the first light of this universe. So this picture was taken on November 23rd last year because I got an award called RCA Armstrong Medal. Radio Club of America, one of the oldest organization, they give an award in the name of Armstrong. This is the man Armstrong. Many of you know about AM FM radio, right? Radio Mirchi's FM something. That's all I know. So this Armstrong was the one who actually invented the technique of AM and FM. And in his name, there is a radio award, Radio Science Award that is given. I was very fortunate to be selected for that award. I got this award from Bob Wilson, none other than Bob Wilson. That's why I wanted to show about, he's the detector of the first light of the universe. So what is the place of us in this universe? What you see is the blue dot. This was said by Carl Sagan. That's here, that's the home, that's us. This picture was taken in 1990 by Voyager 1. I showed you Voyager 1, picture of Voyager 1 that has 24 billion kilometers away. That picture was taken. This is the first time we took the picture of our planet Earth from outside, from outer space. This is the first time we took the picture. And then in 2014, this picture was taken by Curiosity rover from the surface of Mars. This was the first time. What you are seeing here, this is an electronic thing. You cannot put a pointer on an electronic screen, so I will be able to show you the pointer. But what you see on that dot is actually our planet Earth. If you expand it, you see the Earth and the Moon. This was the first time we pictured our planet Earth from the surface of another planet. So sometimes we think that we are very big. We know everything. That big ego we all have. So I tell students that whenever you feel that way, please think about this picture. Because in big scheme of thing, we are just a dot in the sky. And hopefully it will all ground you. And if you're an electrical engineer, you know grounding is very important, right? So again, I said that what exactly we are doing, I'll tell you a little bit about science. Because what NASA does, develops all cool technologies that we know. But that is not our main job. Our job is to do science, answer big science question. Everything that we do starts with that. What is the big science question we are trying to answer? To answer that big science question, what kind of measurements need to be done? To do that measurement, what kind of instrument you need to build? To build that instrument, what kind of technologies that you need? And what are the technology gaps that exist? And that's where our work starts. To fill that technology gap so that we can build that instrument, do the measurement, and answer big science question. What kind of science question we are trying to answer? Are we alone in this universe? This is the biggest science question today for all of us. Is there life beyond planet Earth? I'm sure many of you have seen all the aliens pictures on YouTube, right? Don't believe them. Because there is no life outside our planet Earth. We have not found anything. Not even a single cell. So if your friend says that they have seen an alien, please ask them come to talk to us so that you stop spending billions of dollars. Okay? we have not found. But the question is there possibility of finding life outside planet Earth? If you ask me, what will be my answer? Let's do a thought experiment, what you call it back of the envelope calculations. When you look in the sky, when the sky is clear, not polluted, so that you cannot see the moon even, the clear sky, when you see billions of stars. Our galaxy is the Milky Way galaxy, Akash Ganga we call. We have about 400 billion stars in our own galaxy. 11 zeros after 4, 400 billion. And in our universe, we have about 200 billion galaxies. Now do your math. How many stars are out there? And we are finding the majority of these stars has planets around them. Not only one, multiple planets. The question is, what is the probability that we find one such planet in these trillions of planets where conditions are such that life can exist? That probability is non-zero. And that's why we believe that life could exist outside our planet Earth. On top of that, we have already found many of the planets where conditions are such where life can exist. Only problem is the nearest one that we found is about 4 light years away. See, 422 light hours away is the Voyager. Other one is 4 light years away. It will take 1 million years to reach there. So with current technology, you won't be able to go there. So we'll have to learn from sitting here or going to space. Problem is we don't have the technology. Our instruments are not sensitive enough. One of the reasons that I travel thousands of kilometers to come here and talk to you, because I am asking you to join us and help us develop the next generation of technology that you can use to actually find out all this, what is happening in all those planets. What are you looking for? Life? What kind of life we are looking for? We are actually looking for our kind of life. Hydrocarbon-based life. It needs water, it needs oxygen. You might say there could be other kinds of life, right? Of course. How do you search for it? What do you search for? You don't know. We can always search for what we know, what we understand, right? And that's what we are doing. You know, there is a beautiful poem by Rabindranath Tagore. I say in Bengali. I'm a Bengali, so of course. Janar majhe ojanare korechi sandhan. It translates to, we search for the unknown with the knowledge of the known. That's what we can search for. But there could be other kind of life, but you don't know what to look for. We might stumble upon them. So that's what we are doing. But is there possibility of finding life in our own solar system? What you are seeing here, Enceladus. Enceladus is the moon of Saturn. Look at this. Water is gushing out. What you are finding is water is gushing out from that planet. It is a very cold planetary body. All ice. If water is gushing out, there has to be a source of energy. If there is a source of energy, if there is a source of water, is there life? We don't know. Actually, this detection, this picture was taken by one of the instruments that where I actually built part of that instrument. So I'm very proud of that. What else is coming out other than water? We don't know. So NASA is planning a mission to go to Enceladus and see what is available, what is coming out. Very exciting. Another very exciting body is Europa. Europa is the moon of Jupiter. It has, it's very cold planetary body. It has thick ice shell, but scientists believe there is a liquid water ocean underneath the ice shell. The thickness of the ice shell is about 15 kilometers or 100 kilometers. So if there is a liquid water, that means there is a source of energy. There is a mantle. So if NASA comes to you and asks you what kind of instrument you are going to send there to find out if there is life in that water, what will be your answer? The obvious answer is that we send a drill, we drill a hole, lower a bucket and see if there is any fish. I'm in West Bengal, of course, we'll look for fish. The problem is it takes about 7 years to go to Europa. And the total amount of energy that is available, power that is available to you for this kind of missions is about 400 watts. 4 light bulbs, right? What kind of drill with 400 watts can drill 15 to 100 kilometers through ice? Not possible. Then you have to start thinking. That's where the innovation comes. We are actually just launched the Europa Clipper mission that is going to go to Europa and trying to find out about this. There is some radar, ground penetrating radar, there is some spectrometers, all kinds of stuff that we have on that. So wait for 7 years and I'll let you know what happened, what we found. Space is a long-term business. It doesn't happen just in a day. And you all know that we keep going back to Mars, right? Why? Mars is our closest neighbor. Not only that, actually if you look at the early history of Mars, it looks so much similar to our planet Earth. We started sending all these rovers. 1996 we sent the Pathfinder, very tiny rover. And then Spirit and Opportunity twin rovers we sent in 2003. Then Curiosity 2011, and the latest one that we sent is called Perseverance rover in 2020. And it's doing amazing experiments. It went to a place we believe there is a dry lake bed. So that might be a very interesting place to find if there is life. We didn't find any life. The question is, was Mars ever habitable? Is there life there on Mars today? If I take, there is very challenging to go to Mars, I'll skip that. If I show you these pictures, like one of the picture on the left, and tell you this is actually one of the roads in Durgapur road when I was coming during monsoon, you might believe that. But no, these are all from Mars. Look at these pictures. It looks so much similar to our own planet, right? And if you look on that picture, on this picture, we get this kind of terrain only when there is flowing water. When you go to Mars today, you don't see flowing water. The question is, what happened? Where did the water go? Can it happen on our own planet? What can you do to address that? These are big questions for us. That's why we're trying to send all these rovers to understand what is going on. And we are also doing some technologies, this kind of stuff, or ORISIS. But one thing I'm going to tell you about, just recently, someone asked me that, you have read in the WhatsApp recently that there is a asteroid coming to our planet that's going to destroy our planet Earth and stuff like that. We don't know which direction. So some journalist was asking me, is it going to destroy our planet Earth? What is NASA doing? Right? I actually wanted to ask him, what is ISRO doing? Why should only NASA should look for those things? We have limited budget. But anyway, we are still doing it. We are tracking all those different asteroids which is coming on our way. If you see, there are a lot of asteroids and all different sizes. The majority of them are small, 25 meters or so, but there are many of them. We are not able to track all of them because they're too small. But they're not that dangerous because when they enter the atmosphere, they mostly burn. Problem is the bigger one. But bigger ones are easy to track. So, if there is an asteroid really coming our way, we started thinking, what can we do? So what we did, this is the experiment we did, we call DART mission, Double Asteroid Redirection Test. So it's interesting that we found an asteroid between Mars and Earth. It's a dual asteroid. There's a bigger one at the center called Didymos, and the smaller one, Dimorphos, it is going around it. So we sent a small spacecraft and went and hit the small one and tried to see that can we change its direction. If we are successful, what will happen is if something is coming on our way, we can send a small spacecraft, hit that, and we need to change the direction just by 0.1 degrees or so. then it will miss us, right? Were we successful? Let's see. So as the spacecraft was going to hit, our dart weighs about 570 kilograms only, not that much, very small. And we took all these pictures of the asteroid, the smaller one that we wanted to hit. And look at this, bullseye. We hit that asteroid. And their original orbit was 11 hours 55 minutes. After we hit that, orbit changed to 11 hours 23 minutes. It's enough. So guys, all of you are safe. So asteroid, even if it comes on our way, we have the technology to save us. So no worries, don't send me WhatsApp messages, hey, is it true? Are you going to die tomorrow? My classmates do that all the time. Okay, we'll talk about water a little bit and talk about technology, okay? I know I'm running out of time, but I'll talk a little bit about technology development, how technology development starts. This is about water. As I said, water is one of the most important things of life because life sustains with water. How many of you know that when our planet Earth was created, there's no water? Scientists believe that comets brought water to Earth. And if I tell you that, you say, you are an engineer and scientist, you always ask questions. I see press written here. Press always asks questions. You will ask, how do you prove it? Very good question. How do you go about proving is that, that water has different colors. Of course, you studied that water is a colorless, odorless object when you're in high school. What do I mean by color is that there are different kinds of water. That water that we are going to drink here, this water, is H216O. Oxygen has isotopes. The most abundant water is H216O, but there are other kinds of water. H217O is an oxygen isotope. H218O. HDO, one hydrogen, one deuterium, one oxygen also makes water. And we all know about heavy water, D2O, that is used in atomic power plants. If you take the ratio of abundance of all these different kinds of water and the ratio of D over H, how much deuterium and hydrogen we have, we find that our ratio is very similar to what is there on some of these comets called Jupiter family comets. If the abundance ratio is same, the source has to be the same. But unfortunately, we have done only about 10 such measurements so far on comets. Not statistically significant enough. So I started thinking, okay, that is a big thing to answer, right? So I came up with a concept that can we make an instrument that is this small, kind of shoebox size, but it can do all those measurements that we are talking about, and then take the ratio. The name of the instrument we call Water Hunting Advanced Terahertz Spectrometer on an ultra small platform. Mouthful, what's up? The reason is trying to answer the question, what's up with water? Maybe for the acronym only my proposal was funded. Anyway, so we started working on that. So as I said, that we'll have to really start thinking about technology gaps. How does innovation happens? So let's talk about this water, different kinds of water I talked about. Why I said color? Because all of them has spectroscopic signatures, frequency. You have done spectroscopy experiment in your 12th grade. In our time, we used to do that. Sodium line, sodium vapor line, we used to look through some slit and to see a line because that is the frequency of sodium vapor. Like all of them has spectroscopic signature. You can see the frequencies, 509 gigahertz, 557 gigahertz. These are not just numbers. You know what 500 gigahertz is? Your cell phone has Wi-Fi, right? All of you has Wi-Fi and Bluetooth. What is the frequency of your Wi-Fi and Bluetooth? Sometime about 5 gigahertz range. But we are talking about 500 gigahertz. So much more challenging in terahertz frequencies. So this is the block diagram. Our aim is to make an instrument that will be about 2 kilograms in mass and draws 5 watts of power. The previous generation of instrument was like this desk. How much will it weigh? Not 2 kilograms. And need to draw hundreds of watts. So it is extremely challenging. So you'll have to innovate. How does innovation happen? You do not wake up in the morning, one morning, and say, let's innovate something today. It doesn't happen that way. How does it happen is you actually face these challenges. If you go through this block diagram and see what is available, what is not available. You need a very low aperture, low profile antenna. It is not available at this frequency. You need to calibrate your instrument. You need a switch that does not exist at this frequency. If you want to buy, you need a synthesizer. If you want to buy something like that, it weighs about 10 kilograms and draws more than 20 watts. My total instrument power is 5 watts. So you'll have to innovate. So we actually started looking at all these and came up with these solutions, and actually we did. We made a switch that is working at this frequency. You can see here, there is some waveguide there. Waveguide is like pipe. We need mechanical engineers. The dimension of that waveguide, that what we have drawn there, is about 250 micron by 500 micron. If I say this number, I say, what is 500 micron? The thickness of your hair is 150 micron. So this is cutting metal with a piece of hair. Just think about it, and with the precision that is needed. So it's extremely challenging, but we did that. If you actually can click on this photo, there's an actual picture of that. Can you click on that one at the bottom, that one? Bring the mouse and click on it. If you can find the mouse, of course. This one. Bring it on the right, right. Yeah, here, just click on it. Just click on it anywhere, yeah. Yes. So what you are seeing is actual video of this stuff. This is 150 micron, about 200 microns. So we actually move these with a piezoelectric motor, and it works as a switch. So it's amazing. We have a patent on that. So we are able to solve these problems like this. And also then we needed some load. Many of you know SOCs. If you are working in your VLSI lab, you know SOC. SOC stands for System on a Chip. That's exactly what is there in your phone. All the chips in your phone, they are SOCs, System on a Chip. So what it does, that entire system can be developed in a single chip on a 65 nanometer CMOS technology. So we actually built a synthesizer that works at 90 gigahertz and a spectrum analyzer that works, but that draws hardly any power. 10 watts power is actually a synthesizer box, but that chip draws only half a watt. Then we have developed a spectrum analyzer. In your lab, many of you have seen spectrum analyzers. If you are an electrical engineer student, this big box. This is a single chip spectrum analyzer that draws 1.6 watts. So then we put everything together. This is my WhatsApp instrument, 2 generations. You can see here, one with the reflector antenna, one with the lens antenna. What is the size of that? This is actual picture of that in the lab. You can see this much. This is the entire instrument, and drawing less than 5 watts of power, 2 kilograms of mass. So we wanted to actually fly on a balloon and see if everything is working or not. So you can see here there is a Bob the alien there on the balloon. I have put for a reason, because from where we are launching the balloon is a place called Fort Sumner, New Mexico in US. There is a town very close to that place called Roswell. If you have not heard of it, after the talk you can Google search what Roswell is. Okay. So people in Roswell believe that first alien landed there. And if you go to the town, it's an eerie town because all these things about alien stuff. And because we have launching the balloon very close there, at the end, of course, balloon is going to land somewhere else, and it might land in Roswell. So we thought that we'll put our Bob the alien so that they will discover the second alien if they find our balloon. So this is all the stuff before the launch that I am the PI of that, and we are all the team. Then I'll show you the video of the launch because it's very interesting how it actually goes up. Again, it's a small instrument that we are trying to explore. It will go up 120,000 feet. So the airplane flies about 35,000 feet. It's actually much, much larger. You can see very high-tech launch. We are holding it by hand and they're just releasing it. That instrument goes up all the way. And then it went to 120,000 feet and then send the data back. Now, of course, you know, there is a parachute. When the balloon, at the end, it comes down, there's a parachute. Unfortunately, our parachute didn't work very well. So our instrument, when it landed back, it landed at 40 miles per hour. 40 miles per hour is 40 miles, you know, 40 times 1.6, that is those many kilometers. 65 kilometers per hour is a big accident. So this is what we found afterwards, after it crash landed. So we took it back to our lab. We found the lens antenna came off, but we turned it on, and everything is working just as is. So when we send something to space, we call something shock test. We have to do a shock test. For this instrument, we wanted to do it. Shock test is done. It survived the shock test. And what I'm showing here, you can see the data. So this instrument is working perfect. It's working great. So what we are waiting for now is to get a ride. So next time there is a mission going somewhere, we'll actually launch a couple of these instruments. It will throw us out on the way, and it has its own propulsion. It will go to the comets, do the measurement, and send the data back. Then we'll be able to answer for once and all, did comets brought water to Earth or not? And that is the excitement, that when we build something in the lab, it goes there and answers a big science question. You know, no award, no rewards is more exciting than this. And that's what we are going to do. We are just waiting for it. I'll just end with two more slides, talk about a little bit about Mars helicopter ingenuity. Many of you know that we are flying an helicopter on Mars. You might say, why? The reason is that when you have a rover on Mars, it cannot go everywhere, right? It has limited mobility. On top of that, it takes about 13 minutes for signal to reach to Mars from Earth at the speed of light because of the distance. So it cannot really do drive from here. And so we thought that can we have a rover, a helicopter or a drone that can take off and go around and see what is interesting and send the data back, and then the rover will go there. So you say, okay, we see helicopter in our sky all the time. What is the big deal about helicopter on Mars, right? The big deal is, if I can go there, is Mars atmosphere, density of Mars atmosphere is only 1% of planet Earth. So when a helicopter flies here, the rotor blade rotates at about 450 RPM, revolution per minute. But same helicopter, if you want to get the lift, it has to rotate at about 3000 RPM. Extremely challenging. So we built this, and also it is a small helicopter, so it's not very stable if it is going that high speed. So we have to stabilize everything. This is a completely autonomous vehicle. It flies on its own. It has a gyroscope and all these. There are a lot of sensors. It actually takes pictures and takes all the data and sends it back. Plan was that we'll have 2 to 3 flights maximum. We'll show that this technology works. So it was mounted. I'm going in the wrong direction. Yes, I don't know why. Okay, so it was mounted under the belly of the rover, Perseverance rover, and there was a cap that protected it. You can see we dropped that. These pictures all from Mars, taken by the camera that was mounted on the rover itself. You can see that slowly the helicopter is put down on the ground. And you can see here, this is the helicopter on its own. It has its solar panels for power, 220 watts. And you can see the track marks of the rover. After it dropping, it moved away. And it was standing at 40 meters from this and took some photos and videos. And it is very cold. You can see here at the bottom on the right, that's where the helicopter is, and that's where the rover is, about 40 meters away. And this is the first data that it sent back, first flight of the helicopter. It went about 10 feet above the ground. It was there for about 40 seconds. That happened in 2021, April 19. We were all waiting. It was 3 a.m. in our time. We were waiting, will it work? Because the first time we were trying to fly something on another planet. And then it took off. There is a video here that you can see. That's where the helicopter, this is the real video, came from Mars. You can see the helicopter, the first flight. This is Mars behind you. And the helicopter went up all the way about 10 feet. And it hung in there and then made a 96 degrees turn. Why 96 degrees? Why not? Just wanted to see that it turns. And then it came down at the same spot. And we actually flew something for the first time on another planet. This was amazing feat without a doubt. And then, as I said, we actually planned for only 2 to 3 flights, right? But we tried to, this little instrument was not breaking down. We tried to break it down. We are trying to fly as fast as possible, as far as possible, as high as possible, and see where it breaks. We had, as I said, planned for 3 flights. After 72 flights, while landing, last year in January 18th, about a year ago, while landing, it actually made a tilt, and there's a big stone there, and clipped his wing, and it rested. So that's what we are talking about, this technology. I wanted to show this slide for that, because when you are designing something with dedication, even if it's planned to last for only 3-4 flights, it can go for 72 flights on another planet, harsh conditions. So always think about this, that when you are designing something, when you are doing something, do the best that you can. And that's what we strive for. And with that, I end. Thank you so much. Is there any question and answer session?
Question answer session.
Sure, go ahead.
Fine. Thank you so much, sir, for your profound, enriching, and inspiring presentation. May we now invite questions from our audience and make this interactive session worthwhile. Audience, your questions, please. Sir.
Anyone has any questions?
Yes, sir. Hello.
Yes, I can hear it.
Hello, sir.
Yes.
My name is Shamali Bose from third year EC department. Can you please share what inspired you to become a scientist and how did you end up working at NASA?
The question was great. So what inspired me to become a scientist? What is the definition of a scientist? Who are scientists? I think all of us are scientists. Every single person is a scientist, I think. Why? The job of a scientist is to find the truth, to find how things work. That's all we are trying to do, right? So we see something, some phenomena, we see how does it work. And that's when I was a kid, I used to read newspapers. We didn't have the economic background to buy newspapers at home. So there was a club nearby. There used to be Statesman and Anand Bajar Potrika come every day. And my brother and I, we used to go there first thing in the morning before they can take the newspaper away. And we used to read from first page to the last page, including the advertisements, all of it. And there we used to see about exciting science news, that Richard Feynman at Caltech is doing this kind of stuff, something exciting happening in the space. That actually inspired me to become a scientist. And because I also wanted to figure out how things work. I'll give an example. Many of you have seen a water tank on the roof of your building, right? All of you have seen. Now, next time we look at that tank, you will see there is a pipe that goes above the top of the tank. And many places there is a T structure on that. Have you ever thought, why is that pipe there? If you ask the plumber who has fixed that pipe, he won't know why it is there, but he knows, he or she knows that you need that, otherwise it's not going to work. So that is the kind of things to actually excite me. I used to ask this question, why? Why is there? I used to ask, how come later on microwave ovens work? Have you thought of how microwave ovens work? You have to think about it. You can put a papad and it actually, roasted papad comes out of the microwave oven. You know, you can do something before you put that papad in that to roast, sprinkle some water in that microwave. And then put the papad and then you put your microwave oven on. You will find it is much more uniformly roasted. Why? So these things made me think about to become a scientist, because I was asking questions. You know, as an Indian, we don't ask questions to the teachers. We ask questions to ourselves. And for NASA, as again, who doesn't want to go to NASA here? Can you raise your hand if you get an opportunity? This is a dream place. And the story is that when I was doing my PhD at Caltech, I was in electrical engineering, but my thesis advisor was in the physics department. Caltech allows that. Caltech is a very small place, only 2,000 students, 900 undergraduate students and 1,100 PhD students. But Caltech produced 43 Nobel laureates. And I used to sit in my office in the physics department, and every winter, 2 doors from my office, the person who used to sit, his name is Stephen Hawking. And I used to go and talk to him. So this is, then as a kid, I used to dream about all this, you know, as I said, about space, NASA, Richard Feynman. Then I used to pinch myself that, am I still dreaming or is it real? And then when I was finishing up my PhD, then one day I got a call saying that, okay, we are from NASA and we know about your work and we read about your paper. Are you interested in working at NASA? Luckily, there was no video phone. Otherwise, they just seen me, I'm jumping up and down. I said, yes, of course. And then I went. And even now, you know, every day I feel this is the first day of my work. I'm so excited. That's how I landed up there.
Thank you, sir.
Any other questions?
Good evening, sir. Here.
Oh, great. Thank you.
Sir, my name is Kamna Kumari. I am from first year CSE department. Sir, my question is, what challenges did you face in your journey and how did you overcome them?
The question was what kind of challenges I faced in my journey and how did I overcome that? Did you all face any challenges in your life? Anyone? Of course. All of us. Every journey has its own challenges. Some challenges that somebody faces different kind of challenges than I faced. My first challenge was that I was born in a very poor family. We grew up in a single room home, 12 by 14 feet. We had asbestos roof. There was no floor. Floor was mud. We did not get 2 meals a day sometimes. We didn't have electricity at home till I was in 9th grade. So we are 6 siblings. In a hurricane, one single hurricane, we used to sit around. And my brother and I always used to sit across where the shadow of that hurricane is, so that we won't have to study. And my brother, actually, he lives here in Durgapur. We studied in the same class, same grade. My parents admitted him one grade ahead because we'll have to buy only one set of books. So sometimes he used to read, I listen, and sometimes I used to read, he listened. That's how we studied. So we had some challenges that you might say. How do you overcome? My parents used to tell one thing, that people like us who are that, I'm not alone though. You know that I know many of you will have similar background perhaps. But for people like us who has that kind of economic challenges, only one thing we can do, work hard and study well. That's what we did. All our 6 siblings, we actually worked hard. We studied, and that's how we overcome. That is the way.
Good evening, sir. I'm Shreya Kumari from CSE Department first year. Sir, why do you think exploring space is important for humanity?
Okay, very good question. Generally, the corollary to that is, why are you going to spend all this money when we have so many problems on planet Earth? People are unable to feed, and I was expecting that kind of question. Exploring space is important because, first of all, humanity wants to explore from the beginning. We want to know the unknown, right? And space is such a thing that so much is unknown. Even when we see I talked about all these stars and galaxies, our observable universe is only the 4% of the real universe. The rest of it is dark matter and dark energy. And we don't know much about it. So that's what we want to know. But on the other side, when you are developing space technologies, that actually develops all allied technology that helps us. So you are all using communication devices as smartphone. Many of those were actually developed for space applications. Now we are getting benefit of that. That's why, and apart from science, space is a big economic driver now. If you look at number of companies who are launching satellites, LEO, low Earth orbit satellites, is becoming a huge business. It will be $1 trillion business. The next job for you will be in space, perhaps. So that's why exploring space is very important for scientific purposes, for economic purposes as well.
Thank you, sir.
I am very impressed. The questions are coming only from girl students. Thank you. And now I know that some boy has to ask something. Okay, go ahead.
Good evening, sir. I am Ritika Shreya from Information Technology Department, and my question is, being a scientist, you have seen the beauty and complexity of space. So do you think there is any room for God or higher power in our understanding of cosmos? And how do you reconcile spirituality and both of it?
That is a very loaded question. Okay, I'll have to be very careful about how I answer it. Okay, so as a scientist, we generally believe in observational proof, right? So when there is a theory, people give theories like this Big Bang theory, that the universe started with the Big Bang. That is a theory. Now we are observing the universe, we are trying to get some data, and we are finding that more and more the data that you are getting fits in well with that Big Bang theory. Tomorrow we might find some observations that tells us it's not fitting the Big Bang theory that we have right now. Then as a scientist, we'll have to say, okay, we'll have to change our theory, that the model that it comes through. There is another model called steady state theory. It has not proved that way because all the data that you are getting, the ever expanding universe and stuff like that, is not matching out. Now, for I have absolutely nothing against spirituality. Or if you want to believe in some superpower, you can believe as long as it does not hurt someone else. Your belief should not hurt someone else. That is my basic philosophy. And beyond that, it is all individuals. I talked about God. So, in scientifically, you have not seen anything, any higher power, right? If you think about from scientific perspective. But our knowledge is very limited. We know so little. One thing I always say that more you know, more you realize how little you know. So in this particular case, we had whatever evidence-based science that we do, as a scientist, I'll have to believe in evidence-based science. So again, I have nothing against anyone's belief or spirituality. Spirituality is very different. You can think about it, gives you peace of mind, fantastic. Go for it. Let us do our science.
Thank you, sir. Good afternoon, sir. I'm Nishat Mondal. I'm a first year student from Electronics and Communication Department. My question is, what skills or qualities are important for a student who dreams to become a space scientist like you?
So I missed because the audio is not good here. So can you repeat that part, that what qualities?
What skills or qualities are important for a student who dreams to become a space scientist like you?
Okay. The question was, what are the qualities that you need in the students to become a space scientist or any scientist of any kind? You already have that quality. One of the quality that is needed, that you should be fearless and ask questions. Thank you. So that is one of the qualities that you need. The other thing that you need, there is no special recipe. In many of you, I am in West Bengal, so Ramakrishna Paramahansa, he had said one thing, Joto moth toto poth, right? So if you want to reach somewhere, there are multiple paths. There is no single path that you can reach. So I will suggest you, decide your own path, how you want to reach there. But qualities that is needed is not like you'll have to learn about AI, you have to learn about machine learning, you'll have to learn this, learn that. None of this is important. What is important is whatever you are learning, whatever subject you are studying, be passionate about it. Because if you are passionate about something, even if your parents say, most of the time our parents used to say, study, study, study. But if you are passionate about it, your parents won't have to tell you study. You are going to study that. You are going to understand that. So be passionate about whatever you are learning. It doesn't matter, it's mechanical engineering, for space, we need all kinds of disciplines. We need someone who can write well, who can speak well. One of the job of a scientist is to explain what we are doing. So speaking well is also important, that you did. Thank you. Writing well is important. Understanding of the basics is the most important. That how things work. Don't run after marks. You will see, if I don't get mark, I'm not going to get interview. I know. That's our system, unfortunately. But if somehow you manage to sit across an interviewer, I interview a lot of people to hire at NASA. I don't look at what kind of marks they got. We start talking to them. Our interview is very different. We go out for coffee and start chatting. I don't ask them to solve equations. No way. We start chatting. If I talk to you for 5 minutes over a cup of coffee or tea, I will know how much you know. and which depth you know. Are you giving me BS and blah, blah, blah? I will understand. So one of the advice, if I may, will give you that if you are in an interviewer, if you don't know something, say I don't know. Never try to give some blah blah, because that hurts you significantly. It is no shame in saying I don't know. You are not supposed to know everything. If you know already everything, then why are you here? Right? When I apply for a job, then they say, oh, they're tick mark. You are saying, okay, you tick mark everything. If I tick mark everything, then what I'm going to learn in that new job? Then I'm not going to take up that job because I don't have any potential to growth. So you should go there and be honest and say, I don't know. I am here so that I can learn. These are the qualities that you need to be successful.
Thank you, sir. Thank you, sir. A pleasant good evening to you, sir. My name is Lucy Kumari from Data Science Department.
Can you raise your hand? I cannot see where you are.
Sir.
Okay, there. Okay, thank you.
A very pleasant good evening to you, sir. My name is Lucy Kumari from Data Science Department. My question to you is, what is your favorite space fact or mystery that still amazes you?
My favorite science is physics. You know, physics is the underlying science of everything. Mathematics is the kind of language that is used to express. But physics is the basic science. So I always try to understand what is the physics behind it. So some of you work on antennas, and I'm the track editor for one of the antenna transactions. So paper comes to me, and I see someone has cut something called microstrip antenna. They cut something here, cut something there, and did some experiments, and this is an antenna. I ask them, before cutting a corner somewhere here or there, did you think about the physics behind it? That what is going to happen if I cut it here? What is the physics? How will the surface current will change? If the surface current changes in certain way, what will happen to the radiation that actually, what is the radiation pattern in the far field? You take the Fourier transform of the field in the aperture, right? The antenna expert is sitting here, my friend Parui. He is nodding that, yeah, that's what. So try to understand the physics. That's what is my favorite science subject. I don't know whether I answered your question or not, or that this was the question you asked.
Thank you, sir.
Very good afternoon, sir.
Okay, thank you, male voice. Okay. Where are you? Okay.
Sir, my question to you is, what is space-time and time dilation, and how does it affect our astronauts and the space researchers in their space exploration?
Okay. So space-time dilation, these are things that you can Google and actually read about it, right? So our astronaut doesn't go through the space-time dilation because they are not going at the speed of light, or that will impact them in that way. So in our world, we are more about in the classical domain, if you think about it, Newtonian physics. So if the quantum physics comes in when things are very small, we are looking at very small level, and Einstein's physics coming when we are actually trying to go at the speed of light. We are not there yet, right? So our astronaut world is more in the Newtonian physics domain. So we do not consider the space-time dilation for astronaut, travel. Okay, more questions.
Good morning, sir. Himanshu sir.
Good evening, sir.
Okay, no problem. Go ahead.
Himanshu Sharma from Data Science Department. Sir, I want to ask that how AI is play a role in space exploration?
Yes, there's a question. I knew it's coming. How AI plays a role. AI actually already has been playing a role in space exploration. One of the last rover landing that we did, we actually used AI because AI can be used and can significantly help you. One of the thing was when the rover goes down and there is a surface wind on Mars, and we do not have an anemometer going around and telling this is the wind speed at that time. And if we, what happens is that it actually takes the rover away from where you want to land. And problem on Mars is there are big boulders nearby. So if you don't land on the right spot, it might land one of the boulders and your spacecraft will go, your rover will go belly up and you have lost $2 billion instrument, right? So you'll have to be careful. So what we did, we actually collected a lot of pictures. We have something called MRO, Mars Reconnaissance Orbiter, that is going around on Mars. So we selected a spot and we took a lot of pictures, machine learning. So we actually taught our rover, the computer that we had, that okay, these are the pictures. So as it is going down, it was comparing all the landscape with where it is going, and it found that we are moving away from where you wanted to land. So it automatically, turned on the thruster and was able to move it away from those and land at the right spot. So AI is going to play a big role. It will be disrupting as well. So it all depends on how you use it. So we are using AI to fine-tune our design, what we do. So yes, in space exploration, AI is going to play a lot of role.
Thank you, sir.
I think we exhausted all questions, or
Sir, I think
it's done, right?
is over. So 1 second, sir. We need to do a formality with you right
Sure.
now. Thank you, sir. Thank you, sir. Thank you, audience, for making this session really interesting and interactive. May I now request Professor Dr. Gautam Chattopadhyay to kindly inaugurate and to declare the official opening of the TechFest Horizon 2K25. Sir, please.
Thank you again for organizing the great TechFest 2K25. I officially declare the TechFest open. Thank you.
Thank you, sir. Thank you once again. Thank you, sir. Thank you, audience. We have been successful in establishing our connection with our online guest once again. On this occasion, may I welcome Professor Dr. Glauco Font Galland, MGA, Vice Chair, IEEE. Copy. Thank you, ladies and gentlemen. May I request Professor Dr. Glauco Font Galland, MGA, Vice Chair, IEEE MTT-S, along with Professor Dr. Chinmoy Shaha, Chair, IEEE MTT-S Region 10, and Associate Professor, IIST, to this momentous occasion. With this, may I request Professor Dr. Glauco Font Galland to deliver his inaugural address on the auspicious opening of the IEEE MTT-S Students Branch Chapter at Dr. B.C. Roy Engineering College, Durgapur. Sir, please.
Glauco.
Yes.
You have to speak.
All right, I'm gonna show it. So, good afternoon, everyone. Thank you very much for the invitation. And then, first of all, congratulations all of you for the this new chapter on Durgapur. I think it's very important, and then there's a really big effort from all of you, students and professors. I had to be on that room, join all of them, all of you, and then create this new chapter. So I'm wondering if I can share my screen. There's a few slides. It's not going to take too long. So please let me know if you are able to see these slides. That's wonderful. So right, I'm Glauco Fongalan. So I'm representing Dietmar Kissinger, that's the chair of MGA, as a member of and the Geographic Activities Committee of MTT-S. So again, I would like to welcome everyone for this new chapter, the Student Bench chapter at MTT-S. And then I would like to congratulate all of you. So MTT-S reached his outstanding number of members last year and is still growing. And then this is thanks to India. So if you see, if you're still able to see the slides, so you see this blue curve. So it's our member registration until December last year. And then we reached the mark above 14,000 members. And then this is thanks to India initiative to join more members. And then that is one of the most important things that we'd like to express today and during this at this time. So really thank you all students and professors to get engaged on this initiative. So another point I'd like to mention you is people that are key people that you can join by email through either the website of the MTT-S or through the coordinator. So if you see by the numbers on the top of those little red circles, that's myself. So I'm vice chair of the MGA, and then chair of the student engagement subcommittee. That the goal is to encourage new chapters and motivate new activities. Professor Mohammad is in charge of the DML coordinator. I'm going to talk a little bit about this. He's distinguished microwave lecturer. And Dr. J.C. Chow is the one that approve most of our requests. And then Alexandra is the number 4 is the person that will be in touch with you for many of the approvals that you can request in different ways. And then of course, one of our speakers today is Professor Timoy Saha, that's Region 10 coordinator. So you can reach all those people and others that you may have access and then know that you can request more information about the MTT-S. So become a member of MTT-S and have a chapter chair. A student chapter is not only be a member of a very big society, but also we have a lot of opportunities. So one of them is all chapters have a funding that it can support them to create a local activities and workshops. And that's those people that I mentioned. You can reach them to request or go to the website of the MTT-S.org to check more options. We have many affinity groups that was funded, as well as Women in Microwave, Young Professional, and Site Project. So recently, this year and last year, we have a very nice number of projects that was approved. So also the chairs of the officers of the student branch, in that case, have the opportunity to participate in one of the main conference. In that case, it'd be wonderful that they can request support to participate of METCON, but also it can be able to one of these conference. So as I mentioned, the Distinguished Microwave Lecture program, the main contact is Mohammed. We can request an in-person lecture, a speaker, as well as one online. So all chapters have the rights to request, and then depends on the availability. We're gonna display some people that are the distinguished lecture for this year, that you can contact them as well. So also, all chapters, professional chapters and student chapters, can apply for Outstanding Chapter Award. That's a great opportunity for you guys know how the MTT-S can help you and recognize our effort on doing the administration of the chapter. So we have all the scholarships, and then for undergrad and graduate students participate in competition. The MTT-S has what we call TC, so it's a technical committee. There are specific areas. And then also PhD initiative, like the 3M, 3 minutes thesis, and then student grant travel. So all these opportunities and others, you can have access on the MTT-S website. All right, I'm just want to display the lectures from this year, but 2024 also has lectures that you can request. So there is a time where Mohammed can send email to all chairs. So for you to have an idea about the topic that was covered, we cover active components, wireless power transfer. You can cover new materials and nanomaterials, sensing and artificial materials. Also the topics that cover measurements, and then beamforming. So there's a variety of topics, and those people has a very high qualified experience to present to a large group, and then they are willing to answer all questions that you may have. So right, just to conclude, I mean, I didn't have much more to plan to present to you. I just want to thank you all. And then you might recognize some people on that picture, but one of them that I would like to emphasize is that the person here in the middle, this is Professor Dietmar Kissinger, that is the chair of MJ. So he was unable to join us today. That's why I'm representing him as a vice chair of the MJ. So I'd like to thank you all again, and then congratulate all of you for this new chapter. And then I'll be glad to help you or serve you if you need, as either vice chair of MGA or student engagement subcommittee together with Dr. Chimoy Saha. So I will be glad to answer any question if you might have. And then thanks again for inviting me to participate in this inauguration of the new chapter. Thank you.
Thank you, sir, for your esteemed presence and insightful words. May I request Professor Dr. Chinmoy Saha to kindly say a few words on this occasion. Sir, please.
Good afternoon to all of you, and very good morning to my good friend Glauco. I don't want to take much time because it's the fag end of the day and probably a very long day for all of you, many of you. And to congratulate this new baby, MTT-S BC Rai Engineering College Student Band Chapter, to have a great beginning. The journey starts today. I believe you are already aware of the MTT-S initiatives. Our President, Dr. Gautam Chattopadhyay, is present in person. The MGA representative, the Vice Chair, Dr. Glauco, who is a very good friend of mine, is present over here. And another very old, I think Dr. Bhaskar Gupta, Professor Bhaskar Gupta, probably I can say, tell him that he is one of our mentors, so I can tell him as one of our old friends. So he is also present. So it's a great occasion. Congratulations for forming this new chapter. As you know, already told by Glauco, probably by Dr. Gautam also, the society is very generous. We have a lot of initiatives in all fronts, from MGA side, from education committee, from young professional affinity group, which is a committee, then women in microwave, diversity and equity and inclusion, DEI. We have different kind of initiatives. I chair a subcommittee which is called SITE, Special Interest Group on Humanitarian Technology. So for students, for professionals, for young professionals, for female faculty members, female students, for everybody, MTT-S has a lot of initiatives. So you should take leverage of these. We have DMI, we have DML, Distinguished Microwave Lecturers. We have so many supports to the chapter. We support by workshop funding. We support by chapter funding. We send our high-end speakers to the Distinguished Microwave Lecturers program, Distinguished Microwave Instructor program, which is run by Education Committee. We have a Nano VNA program by which we give the Nano VNA up to 3 gigahertz, as a gesture from the Education Committee to the new student branch chapter. So you must, look into all the initiatives from the MTT-S website and also try to attend the different kind of online and in-person meetings to get maximum benefit out of our initiatives. So I would like to congratulate once again, and as I said, I don't want to make it very long. I look forward to visit you because I am basically from West Bengal but working in Kerala. When I visit to Bengal next time, I'll try to be in touch with you, Dr. Gaur Shankar, who is the person who has started this initiative. I'll try to visit you in person there. Thank you very much for this. I wish you a very good journey, and I will invite all of you to come to Kerala in the month of December 14 to 18. We have a huge event, which is the society's own conference supported by IEEE Microwave as well as Antenna Propagation Society, MapCon, Microwave Antenna Propagation Conference. Students can come, student branch chapter officers will be supported through the chapter chair meeting, and there are many other components which you can see from our website. So an open invitation to faculty members, students, faculty colleagues to submit papers and also attend MapCon 2025. I am always there to support your any initiative, any kind of event you want to do in your campus. All the very best. Thank you very much. Thank you.
Thank you, sir, for your kind and warm words. As we conclude this inaugural session today, it is time to extend our heartfelt gratitude to everyone who contributed in making this event a grand success. On behalf of Dr. B.C. Roy Engineering College, Durgapur, I extend my sincere gratitude to our chief guests, Professor Dr. Gautam Chattopadhyay, guest of honor, Professor Dr. Bhaskar Gupta, esteemed Professor Dr. Glauco Glan, and Professor Dr. Chinmoy Shah, for taking out time from their busy schedule to grace this occasion and enlighten us all with their invaluable insights. A special thanks to our esteemed society members, respected dignitaries, esteemed colleagues, organizing committee, and student volunteers whose tireless effort has brought this event to life. The collective and collaborative dedication and effort of all have ensured that the TechFest Horizon 2K25 becomes a resounding success. Lastly, I extend my heartfelt gratitude to all our enthusiastic participants, attendees, and students for being a part of this celebration of knowledge, innovation, and excellence. With this, we conclude today's inaugural session of TechFest Horizon 2K25. We hope you all have a great time exploring the various events and competitions lined up in this fest. Thank you all. Thank you once again.